Hello everyone, my name is Krishna Kodali. I work in software support group. In this video, I'll be covering about service affected events for the product ITNM, which is IBM Tivoli Network Manager IP edition. So at the end of this video, one should know what are SAEs, how they should be benefiting for NOC operators and ITNM admins. So the agenda is we'll go through the overview and then architecture. I'll walk through the functionality of SAE followed by a demo. There is a reference material here. This is only needed if you have a multi-tier object server setup. What it means is you need to have SAE enabled on the primary / active object server on standby servers that need to be turned off. The steps are pretty self-explanatory, so the link should take you to all the steps that you need to perform. Okay, so let's talk about SAE overview. This is a cross-product feature that was introduced back in 3.7. So you need to have both at a minimum ITNM and Omnibus integrated. And it's nothing but we raise an alert when a member of a predefined service fails. It could be MPLS VPN, it could be IPv4 FAT, and so forth. This feature is on by default in 3.9 and higher versions. It is nothing but we want the NOC operators when their services are affected by one or more network events. The next bullet is self-explanatory, but the key here is if you are a provider and if you want to expand the SAEs to all the possible VPNs, you need to enable forSAE option. That is the one of the advanced discovery GUI option, so that you have all appropriate data between the Omnibus and ITNM. And out of the box, it is mainly around MPLS VPNs. It could be layer 2, layer 3, and TE paths and IPv4 paths and so forth. This is customizable. You can have your own logical collection. Say, for example, you want to have your own set of logical collection for a given location, and then we can raise events when one of the device goes down. SAE used to run as a separate process in earlier versions. From 3.9, it is a plugin for event gateway process. This can be customizable. Say you want to modify the out-of-the-box SAE events, you can enhance or enrich them in some of the configuration files, which I'll cover in the later video. On the Omnibus end, you need to ensure that you have the automations and schemas added to your object server, and the details are in the script on how to run the script, how to add this automation and so forth. Okay, so let's look at the SAE architecture. So since it is a cross-product feature, the ITNM has many subcomponents. One of the component is event gateway. The event gateway itself has many plugins. So you can see here the plugins are RCA, SAE, failover, and so forth. So within SAE we have multiple subcomponents. As you can see here, you have IPv path and ITNM service and MPLS VPN. And within the object server, you have the schemas, which is listed here, and then you have the automation that does the lookups and raise SAE events accordingly. So whenever there is a full or partial discovery, the model receives the updates from a discovery process. It then broadcasts the topology to various other processes, and one of them is being event gateway that consumes the updates, and it pushes unnecessary updates, inserts, deletes to the object server. That's how the topology is kept in sync to have the SAEs generated accurately. What's an SAE event? How does it look and how does it work? In this example, the ready event, which is nothing but a link down event of an interface running the MPLS VPN over that. This is called an underlying event, and The SAE automation sees that this automation runs every 60 seconds. You can tune it, you can modify the way you want. You can run it more frequent than 60 seconds. And it does the lookups. If that underlying event is part of the existing services, we raise the synthetic event to present certain service has been affected. In this case, it has been VC77. There is only one SAE event generated per service. SAE events are always a severity 4 and they are major. When all the underlying events, it could be one or more, uh, when they get cleared, the SAE event gets cleared by itself. The major advantage of SAE is the knock operators can quickly identify the service affecting events. That's the key. Okay, so the next step is making sure the ITNM and Omnibus are SAE ready. This is the twofold check. On the ITNM end, there are many scripts out of the box, and the script we are interested in is ncp gateway plugin.pl. You can run against the respective domain with the dash list option, and then you can see that all the SAE plugins are active. True being active, false being disabled. On the Omnibus end, both schemas and SAE automations are installed using one of the actual script. You can drop and re-add as needed. For example, this is the one to drop both schemas and automation, and the other script is the create SAEs. This one is to re-add both schema and automations. Okay, so in the previous slide we looked at the example of MPLS VPN. This is the extension for the SAEs around IPv4 paths. In this example, we could see there is a link down on Fast Ethernet 0/1 on the New York router, which is this guy here, and then that is going via Pittsburgh to another New York data center. So as a result of that event, we raised a SAE event around that IPv path. So you can right click on the actual the link, and you could get various options. So one of them is service affected events. Again, this can be extended for any logical collection. That's the key here. Okay, so we do have a couple of tools to navigate between the underlying and synthetic events. In the previous example, we have seen the MPLS VPN, and the underlying event is the gigabit 3/4 going down. When you right click on that event, and you can click on show SAE related services, that would bring up actually the second one here, which is the MPLS VPN Edge VC77 affected. Vice versa, you can do for the second event. When you right click on the SAE event, you can navigate to who are the underlying events that trigger the SAE alert. That way operators will know that which interface has gone down. They can go ahead and fix that root cause. Okay, so let's now see the demo on what we have discussed so far. Okay, to keep it simple, I have installed all components on single host. The components being ITNM core, ITNM database, tip, and Omnibus. I have opened 4 telnet sessions so that we can perform all required tasks throughout the demo. If you remember, we had a twofold check to make sure ITNM and object server are SAE ready. Now let's take a look at the ITNM core side. Before we do that, let's make sure we have the environment sourced so that we can run out of the box scripts without being in the absolute path. Source the environment, and let's look for the status of all the components. Now you could see we have the object server up and running, which is Omni 731, and we also have ITNM with the domain name BP Guide up and running. We have the tip instance up and running. I chose MySQL as the database for NSIM. Let's make sure it is also up and running. Okay, so far so good. Now let's navigate to the scripts folder where we can run the Perl script to find the status of SAEs. The scripts are located in $NC home, precision, scripts, Perl scripts. And if we do a listing here, the script we are interested in is ncp gateway plugin.pl. So let's run that script. So against the domain name is BP Guide. You can see here all the required SAE plugins turned on. They are here. Now let's do the same verification for the object server. Let's navigate to $NC home precision script. Let's the scripts we are interested in is SAE SQL scripts. Let's do a more on the create SAE to find out what are the names of the schemas and the automations. So we could see here the database name is precision. We have a couple of table names. One is entity.service, service underscore details, and the last table is here service affecting event, and there is a automation group. The group itself name is SAE. The automation is called update service affecting events. So let's navigate to the admin console for the object server to make sure we have all schemas and the automations created and active. Let's open a object server admin console. I chose the GUI method. There are many ways to validate this. So my object server name is Omni731. Let's navigate to the system and databases. Here you could see we have a precision database. Underneath that you have respective three tables, and the second part is automation. Let's go to the automations, triggers. Let's sort by group to make it easier. Let's navigate down. You could see here there is a SAE group, and the trigger name is update service affecting events, and it is enabled, and the group is also enabled. We now validated both object server and ITNM or SAE ready. Now let's log on to the GUI and create some network views for MPLS VPNs. Okay, I have logged on to the GUI to save some time, and let's log on to the network views. Let's create views that are associated to MPLS VPNs, and you can pick up the type as MPLS VPN dynamic template. For this particular domain, I only have one domain here, which is BP Guide. You have 18 VPNs associated, and you can choose the option whether you want to hide the customer edge devices or you want to display them within the network views. Let's click on OK with the default option. Now let's expand the SAE demo. You could see all the 18 views. Let's pick up the same view we discussed during the slides, which is a VC77. So now I'm going to change the layout to hierarchical so we can have better visibility for the devices that are carrying this VPN, which are these top two devices, which is this and this one. Now let's go ahead and find out what are the interfaces that are contributing for this VPN. Let's do that. Okay, I'm now back to the telnet session where I'm going to log into the database and find out the appropriate interfaces that are carrying the VPN VC_77. Let's log on to the database. The table that holds all the VPN's names is network VPN. So let's look at the context of that. Here you could see all 19 VPNs, including the MPLS core. The view creation was excluding that MPLS core. Now let's look at the entities that are associated to the VPN VC77. We need to join a couple of tables. The other table we are interested in is collects, which holds all the logical collection of these VPNs, and then we need to also do another join with the entity data to find out the actual interface name. Let's do that. I have a couple of predefined queries. So I joined here network VPN and the collects to find the appropriate VPN name. We could see here the collecting entity, which is the logical collection. The members that are part of this VPN are the entity IDs 12929 and 13427. At this point, you can simply run a query against entity data to find out the entity names, or you can do another join to find out the names of those interfaces. Here I made another inner join with entity data. As you could see here, we have the network VPN collects and then entity data joined together, and these are the two interfaces that are participating in the VPN called VC77. Okay, now let's generate a link down event on one of the interface that is carrying the same VPN. I have got a script that generates the fake events without having to bring down any interface in live. So I ran the script here. Let's navigate to AEL. As you could see here, you have the actual link down event from the interface that is carrying the VPN, and you do have associated SAE alert created as a result of that underlying event. You can navigate from here, which are the SAE related services affected by this underlying event, or vice versa. You can click on the same event, the SAE event, and bring out the underlying events that are root cause for that service. Okay, let's close these tabs and let's create one more event for the other interface that is carrying the same VPN. If you now right click on the SAE event and go on the related events, so that will bring all associated root cause events slash underlying events that are affecting that particular service. Let's clear these events. Let's repeat the same thing for another logical collection, which is IPv4 path views. You can see here there are MPLS paths, and I've created manually one view between two data centers, which is this one here. Let's zoom it a bit. So you have a New York data center router connecting to Pittsburgh. So let's find out what are the interfaces that are involved around this. Let's hop over the dotted line to find out the actual interface that is participating in that path. So you could see here the New York router is going through fast Ethernet 0/1. Let's go and raise an alert on that interface. I'm back to the telnet session, and I'm raising an event on that router, which is a fast Ethernet 0/1. Let's navigate back to AEL. Okay, we now have two set of events. One is the fake event which I inserted that resulted in SAE alert. It's the same drill. You can right click on this event, find out the root cause alert for that SAE service, and vice versa. This brings me to the end of the presentation. In my next video, I'll be covering about how to enrich SAE alerts. And thank you for watching.